Hello, everyone. My name is Sarah, and I want to welcome everyone. We have attendees joining us from all around the world today, and we appreciate everyone taking the time to join us here today. Today, we are bringing you a new webinar on Profil, row form design software. For over 38 years, ETA has been the leading provider in engineering software solutions to clients and customers around the world. Your webinar host today will be Jensen Chen, the VP of Global Sales and Marketing Dynaform. Jensen has over 20 years of experience using LS Dyna and Dynaform. We will have time for questions at the end of the presentation, but please feel free to type in any questions you may have in the Q&A section at any time. The last thing before we get started today, there'll be a short poll at the end of this presentation. If everyone could take a moment to fill it out, it would be greatly appreciated. Without further ado, I will turn it over to our host, Jensen Chen.
Thank you, Sarah, for your brief introduction. Good morning, good afternoon, and good evening, fellow engineers. And I hope all of you are having a great sunny summer. Thank you for taking your time to join our webinar regarding Profil. My name is Jensen Chen, and I'm hosting this webinar along with my colleagues, Ming Chang, Curtis, and Mohsin. I will present and demonstrate the capability of Profil for row design. During the presentation, feel free to type your questions via the message box. We will answer your question during the Q&A sessions. Let's take a quick look at the outline of today's presentation. I will quickly cover ETA's corporate profile, following by Profil background and features. After that, I will conduct a quick live demo, and we will continue with polling and Q&A at the end of the demo. ETA was established in 1983 by a group of engineers as an advanced engineering services supplier for automotive industry. We are celebrating our 38th year anniversary this year. But over the course of nearly 4 decades, we have performed engineering services for over 40 full vehicle programs. We are also developing engineering software such as ACP Op Design, Dynaform, Precis, and VPG Suite. A little background about the developer of Profil. The German name here is quite long, so the short form is Ubico. Okay, it is based in Esselau, Germany, which is about 60 miles or 90 kilometers northeast of Cologne. Ubico has over 3 decades of experiences in providing consulting services to row forming industries. Now, what is Profil? Profil is a window-based row design software for manufacturer of cold row form profiles and seam tubes from sheet metal, designer of row formers and tube forming machines. Profil helps to relieve designer of tedious work such as calculating of developed length, drawing the profiles and row tools, compiling part lists, and so on. Therefore, designer is able to fully concentrate on the design of quality profile. Profil also helps to reduce cost in planning, design, calculation, and drawing of profile and flower patterns or the bending steps. It enables quicker, safer, and economical design. Quicker because the calculation and drawing work is done in the background. It is safer because quality management identifies design flaws. Profil improves profile quality through high calculation accuracy and a systematic design process. The market spectrum of Profil ranges from aerospace, automobile, and motorcycle to energy sector and civil engineering. Roll form products such as the leading edge, the fuselage frames, and stringer can be roll formed. In automobile, we commonly see roll form roof bow, door beams, and bumper beams. Roll form solution is also adopted in motorcycle industry. It's used to make the rim and the mud guard. In renewable energy sector, the frames for solar panels is being roll formed. We also use roll forming to produce sheet metal roof, window frame, and even stadium seat frames in civil engineering. Now let's look at the history of Profil. It was initially conceived in Germany in mid-80s. The first version was released in DOS and HP Unix system. In 1997, the first Windows version was released, and over the course of 2 decades, many versions were released. Late last year, version 6.0 was released. Now let's look at features of Profil. It has an intuitive Windows-based user graphic interface. Users can easily navigate through these windows with the help of tooltips. Profil supports different CAD interfaces such as AutoCAD, BricsCAD, SolidWorks, Solid Edge, and ZWCAD. As shown on the right side, we have a 2D profile generated by Profil, which can be converted into a 3D geometry in ZWCAD by using the active interface embedded in Profil. You may design profile using 3 different approaches in Profil. First, we can use a profile design toolbox where there is a parametrics windows that allows you to key in the values of each segment, line segments, and the radius. Alternatively, you can use the numerical methods to quickly define simple profile by manually key in the lines and arcs or the bend segments into the profile lists. Lastly, we can also import the profile created by CAD software such as ZWCAD. We can easily and quickly design flower patterns in Profil by using the toolbox modify feature. Of course, you can also enter different angle sequences from the table or the profile list listed in Profil. Profil supports design of shaped and round tubes, the tube design toolbox, and calibrator shaped tubes, fin passes, and top row for fin pass. The trapezoidal profile forming is also supported in Profil. This feature is widely used for the design of wide sheet metal strips to a trapezoidal profile, such as the roof shingles, the truck bed, and the side frames. There are different design courses that you can choose using these options. Profil provides different approaches of generating raw tools. You can automatically generate row tools by selecting the top and bottom line segments, or you can import the row tool created by CAD software. There is a dimensioning feature in Profil that you can use to create dimensions of objects associatively. So when the object is modified, the dimension will be automatically updated. Here, the statics of the profile is being calculated. Information such as moment of inertia, moment of resistance, area of cross-section, weight, torsion moments, and so on are calculated and can be transferred to CAD system. Profil offered a 3-step quality management concept. The stress band edge is the first step of the quality management concept. Stress band edge is used to calculate the strain of the band edge by using an empirical approach. The relative stress related to the yield strength of the used material will be computed. From here, engineer will decide if the stresses exceeded the yield stress and then how many passes you have to create to reduce the stresses. The second step of quality management is the profile stress analysis, or PSA. Critical bending zones can be calculated with high resolution. The stress related to the yield stress of the material is assigned to a color in the range between blue, green, and red. Red means no good, and we have to change different steps just to remove the red contour. The last step of quality management is the FEA, where finite element analysis is carried out using LS-DYNA for highest accuracy. Both shell and solid strips are supported in the FEA quality management. At the end of row 2 design, part list can be quickly created. It contains the blank size, gross and final weight of calculating material and hardening costs. Part list also contains bushing and spacer. Profil generates NC data for row tools. These data can be used to manufacture rows by CNC lathe. After completing profile and row 2 design, 3D model can be created and transferred to CAD system via the ActiveX interface. That is the end of my presentation. Now I'd like to proceed with a simple live demo of a bumper beam. In this demo, I will present profile generation, the flower patterns, and also the stress band edge and profile stress analysis. Okay, this is the window of Profil. We can create the profile by using the profile list table of windows listed here. All right. In this case, we can select the material from the material list. I have DP980 listed here. And I'm going to change the thickness to 1.5 millimeter. Right. We can also change to the English imperial unit system in Profil if you wish to use that. Right. So in here, we can create the first line, okay, by keying L, then the length. You can see that this segment is instantly created and displayed on the window. Then we can proceed to create an arc with the direction of left and then a radius of 3 and a bend angle of 60 degrees. Okay, and you can proceed to create more line segments. So if you have a very simple profile, it's a lot quicker for you to create it using the profile list. Okay, now if you have very complicated, you can create it using the CAD software and then use Profil to import the line segments. In this case, in a DXF format. This is the CAD format supported in Profil. So in here, we can pick either the upper or the lower segments. Then click OK to import the line segments. All right. You may see the thickness is a bit thin. We can change this thickness to 1.5 and hit enter. All right. To increase the thickness. Okay, so this is the quickest way to create the profile list in Profil. All right. After you import or create the profile segments, you can check the number of passes or stand required to make this profile. We can use the functions required count of stands to estimate the number of stations required to make this profile. In this case, it's listed 17 stations. Okay, but I'm not gonna create 17 stations in this demo. It takes a bit time, so I'm gonna demonstrate how we can create a few flower patterns in this case. So we can append a new profile, and then in here we can change the angle. All right, so we will use this and change this angle to, let's say, 60 degrees, and then the other one on the right side to 60 degrees. And then from this one, we can also append another profile. This time, I'm gonna change this to 30 degrees on both sides. And then we can append the next profile. And now we're gonna change the angles from 30 to 0 degree. In this case, 0 degree. Okay. Now I'm gonna add another profile. In this one, we're gonna remove the 10 degree to 0 degree and change this to 0 degree. All right. Then we can add more stations by using the append functions. This time, we are going to change this from 80 degree, say, to 50 degrees on this side, and then 50 degrees on the other side. And we're gonna add more to change the 50 degree to 25 degree and 25 degree. And we add one more to change 25 degree to 0 degree and 0 degree. Okay, so last one, we're gonna change all this to 0 so that we get the flat strip. Okay, so I'm gonna change this one to 0. All right, 0, 0. All right. You can see that 0. So now if you look at your flower patterns, this is how you create the flower patterns for this product, but not necessarily the right one, because you can use the quality management. Okay, this is the first one, right, to check, okay, if this will pass, right? Or you can use a profile, right? So we have a something is not displaying right. Okay, so we need us to use the machine here. Okay, so in this case, we can demonstrate, all right, with the machines. So we can see that the stresses exceeded the yield, right? So this might not be the good design. Now, if we want to reduce this, we can add more stations. Like in this case, we can create more stations, and then you can change the bend angle. All right, we have this bend angle here from 60. All right. Okay. We can change to, let's say, 45, and then we can change this one to 45. So as you increase the number of stands, you will be able to reduce the bend edge stresses, so into a better range, right? So this is how useful the tool is to help us to design the flower patterns. Okay, you can also display, all right, the profile stress. In this case, you can see that in this zone it's red. That means there's excessive stretching, so that might cause problems in the roll forming process. All right, I will show the whole strip. In this case, we have 9 passes, so there are a few areas that you see red spot. All right, and in this area you can add number of stands to reduce that stresses. Okay, so that's why I say that Profil is very helpful and for designer to quickly design their roll form product. For higher accuracy, you can also use the FEA options. In this case, however, you need to create the roll, so we may be able to carry out this, in the next sessions, because it will take more time to generate the roll for each stations. Okay. So that is the end of my demo. So I think we can proceed to our polling. Ming, if you can, please bring up the polling So appreciate if you can take a couple of minutes to answer all these questions listed in our poll. And after that, we will proceed with our Q&A sessions. Okay, there's I think 3 questions. So once you pick them and then click submit to submit the poll questions. So let's move on to the Q&A sessions. I think we have a couple of questions. Okay, you can see our, wow, that's a number of questions here. Okay, so the first one is, what you're showing us is a static row forming. Is that a capability for dynamic row forming? Dynamic row forming, it's not a common co-row forming process. It's over 90% of the co-row forming process involve uniform cross sections. So that's why this feature is currently not supported in Profil, because we don't have a lot of customers using this feature. Next questions, what kind of result variables can we view using Profil? Okay, we can view, the stresses. All right, we can view the springbacks if we are using the FEA quality management. Usually, we would just go by the stress band age and the profile stress analysis, of course. The next question, can we save profile created within Profil? Yes, we can save the profile created in Profil. All right, in this case, we can use, let's say, we use our example here. All right, we can use the profile catalogs and we can save the current projects. All right, in this catalog. This, however, require the database options, of Profil, right? And it's very useful. If you use that, you can simply open, one of your profiles. For example, all right, we can simply open the profile, and then we can use the save development table. You can open a development table. Okay. In this case, you can apply the previous, work that is similar. All right. Then your bending process of flower patterns will be automatically created. So that will save you a lot of times. Of course, at the initial stage, you have to create all these yourself. But later on, you can save all this into a catalog or a table, and then you can reuse it for, modify the profile. Okay. How is PSA being calculated? This is calculated based on some empirical formula where they will calculate the stretching of, the elements while it's being rolled from one station to the next stations. First the strains is being calculated, and then they will convert the strain into stresses. All right. So, and then from there they will display this in green, blue, and red. Okay. If PSA gives me a stress strain, why would we need to simulate portion with LS-DYNA? Okay. As we know, LS-DYNA is one of the best solver for sheet metal forming. That's one of the reasons why we want to use it together with Profil, because the stress band age and PSA is based on empirical formula. So it's some kind of approximations, and it might not be accurate when we're dealing with, advanced materials such as DP4, 980, advanced high-strength steel, or some other exotic materials. So by using LS Dyna, we'll be able to predict, stress strain or even spring back much accurate comparing to using the other quality management options. Okay. We have a next questions. Can you use Profil for roll designs themselves, such as high stresses on roller, breakage or fatigue, or look at the forces on the bearing? Okay. Unfortunately, no. We are doing the roll design here, so we're not checking the tools wear and tear. In this case, with the roll tool that we created, we can use Dynaform, to check the wear and tear and fatigue and the stresses. All right. Because the normal simulation done in Profil is based on rigid rollers, but we can convert that into a deformable rollers and then predict the stresses, on the rollers. All right. I'm not sure if that helped, but actually, no, we cannot do it in Profil, but we can do it using Dynaform. Okay. So if you guys have more questions, feel free to key in your questions in our Q&A sessions. Okay. If we don't have additional questions, then I'll pass on the torch to Sarah. Over to you.
Okay, thank you, Jensen. Hello, everyone again. We hope you enjoyed today's webinar and found it informative. We'll be uploading the recording of this webinar to our website and YouTube page soon, so please keep a lookout for that. If you have any questions or would like more information, do not hesitate to contact our team members and they will be able to help you with anything that you may need. Once again, thank you for joining us and have a great day and stay safe.